Thank you for that introduction. Thank you all for being here. So today we'll talk about our reflections on an interdisciplinary collaboration in which we developed communications about energy and climate change. We'll start with some more detailed introductions about who we are and what our fields are. Then we'll discuss two projects on which we have collaborated in interdisciplinary teams. And then we'll discuss what we think we have learned from working in interdisciplinary teams. So Granger and I have had an active collaboration for about 15 years. After completing my PhD at Carnegie Mellon in behavioral decision theory and psychology in 1998, I went home to the Netherlands where I worked for 3 years as a postdoc at Eindhoven University of Technology. I started working with Granger when I returned to Carnegie Mellon in 2002. And even though I am not an engineer, like I said, I'm actually a psychologist, I have had an appointment in Granger's Department of Engineering and Public Policy, or EPP, since 2009. In 2012, I moved to Leeds to take up a leadership chair in behavioral decision making and lead the Center for Decision Research. Now, in this center, what we do is we study how people make decisions and about, for example, their finances, their health, climate change. And if we find that people have difficulty in making those decisions, we aim to develop communications or interventions so that people can make more informed decisions. Now, even though I'm now at Leeds, I still have an appointment in EPP, and Granger and I are still actively collaborating.
So I've been at CMU since 1974, where I built a department called Engineering and Public Policy that works on policy problems in which the technical details really matter. And while my PhD's in applied physics, through collaborations that I've had with Baruch Fischoff, Lester Lave, and several others, I've grown a deep appreciation for the insights and tools that first-rate social scientists can bring to the problems that I care about. Insights and tools that I can understand, but given my technical background, I can't really adequately apply on my own. Wendy and I first began to collaborate on a problem that involved understanding public perception of carbon capture and deep geologic sequestration.
So before I met Granger, my main interdisciplinary research project had been to develop an intervention to reduce sexually transmitted infections in female adolescents. The team involved psychologists and medical doctors and was led by Julie Downs. So what we did is we created a video where viewers could recognize decision points in interactions with potential sexual partners and then plan what they would do if they were faced with such a situation. We followed our viewers for 6 months, and as compared to controls, they were less likely to be sexually active, more likely to use condoms if they were sexually active, and less likely to be infected with sexually transmitted diseases. The intervention was later recognized in a review by the US Department of Health and Human Services as one of the few that actually led to behavior change and sexual risk reduction. Now, Granger thought that if I knew how to talk to teenagers about sexually transmitted infections, then surely I could help him to talk to adults about carbon capture and sequestration. I didn't even know what CCS was, but I said, sure, count me in. It helped, of course, that he offered to cover my time because I was on soft money, and that Claire Palmgren was also involved because we had successfully collaborated before. I didn't know what CCS was. I'm not going to assume that you do. So carbon capture and sequestration, in my lay terminology as a psychologist, is a technology that can be added to coal-fired power plants so as to remove its CO2 emissions and put them deep underground. It could help to curb climate change because it takes CO2 emissions and removes them or prevents them from going into the atmosphere. But if people don't like it, there may be public resistance and the technology may not be implemented. So in the early 2000s, we interviewed people about CCS, found that most interviewees had not heard about it, and they felt at best lukewarm after they heard a brief description. Instead, they wanted to discuss and compare alternative strategies for low-carbon electricity generation, such as solar power and wind power. So in a follow-up survey, we gave participants the opportunity to compare different low-carbon electricity generation technologies before and after receiving information about CCS. They rated CCS in the sense that where you put CO2 emissions deep underground, so geological disposal, as well as where you put the CO2 emissions in the deep ocean, oceanic disposal. They didn't like either of those very much. They gave the lowest willingness to pay for both of those technologies, even lower than nuclear power, which can have its own public resistance issues. And like I said, people in this survey received information about CCS. It covered the risks and costs and benefits. And I think what might have happened in that survey is that people focused on the negative information about CCS more than the positive information. We know from decision research that negative information gets more attention than positive information, and losses loom larger than gains. So what we really should have been doing is give people information about the risks, costs, and benefits about all technologies, so that people perhaps could recognize that all technologies have downsides and upsides. And also, they wanted that information about all of those technologies. So in a follow-up project, we developed written communications with then PhD student Lauren Fleischman-Meyer. She involved experts in 10 low-carbon technologies to write those communications, but because experts often use words that are too difficult for non-expert audiences, we pilot tested these materials with intended audience members, and then simplified them to ensure their understanding, showed it back to the experts to make sure they still thought it was accurate. The resulting technology sheets covered the same attributes for all 10 technologies, including how it works, CO2 release, costs, and safety, so positive and negative information for each technology. So here you see the rankings of the technologies before and after a group discussion. The main points are that there were two types of coal plants, IGCC and PC coal plants, with IGCC being a newer technology. Without CCS, they were ranked as the worst two technologies. But if you added CCS to those coal-fired power plants, people rated them better, especially the IGCC plants, the newer types. Lauren also developed a computer tool where people could choose to generate a portfolio that could realistically be implemented in Pennsylvania to deliver their electricity. And that portfolio, the study was done in Pennsylvania. The portfolios that people generated usually included some CCS as well as renewables and other technologies. So what we conclude from that project is that if you give people positive and negative information about a range of technologies, they may be willing to accept the technology that you're trying to communicate about.
Yes. So, as Wendy said at the outset, we've also worked a fair amount on climate change and its impacts. The first work we did together in this space involved trying to see how well people understood secular trends in flooding in Pittsburgh. And so I've shown there a 3 time series, and you can see subtly there is a trend. And in trying to explain this to lay people, we found that it made a whole lot more sense not to talk about climate change, but simply to talk about how to adapt to and respond to specific effects or endpoints. And Wendy has found similar sorts of things in other work that she has done on flooding and impacts in the UK. Over the years, in addition to my work with Wendy, I've also collaborated with several other behavioral social scientists. One of these collaborations has been with Ann Bostrom, who is now at the University of Washington. And with Ann, we've done a number of things, but the 3 papers shown there on the right are first a study of over a decade ago of what the public then understood and believed about climate change and climate science, and then a second study using the exact same instrument roughly a decade later. And based on that work, I developed various communication materials for climate change for lay audiences. But as I talked about this stuff to public audiences, I increasingly came to the conclusion that many of the details really weren't that important. If you want to be an informed participant in public discourse about climate issues and climate change, there are basically 3 things you need to know. You need to understand that burning fossil fuel produces carbon dioxide, that more carbon dioxide in the atmosphere warms the planet and causes the climate to change, and that then once carbon dioxide gets into the atmosphere, much of it stays there for hundreds of years. So if you look at the studies that Ann and I did with colleagues, it's pretty clear that there's been progress on these first 2 points. More and more people understand that burning coal and oil and gas and carbon dioxide they make is the problem. But I had become increasingly concerned that people did not understand this third point. And so Wendy and Ann and I recruited a doctoral student at EPP, Rachel Dryden, and we set out to learn what people thought about the atmospheric residence time of carbon dioxide. Now, of course, we didn't talk about it in terms of residence time, but that's what we were basically trying to understand. And we used, in a variety of other settings as well, we used 2 questions. The first one says, suppose that we shut down all the factories and everything else, how long would it take for common air pollution to revert to the levels before all of those things turned on? And we define common air pollution as, that is pollution like smog, oxides of sulfur and nitrogen, organic gases, fine particles. Then we asked exactly the same question about carbon dioxide. Of course, you know, in the designs, we alternated the order in order to make sure there weren't order effects. There weren't. And we then administered this in 2 studies, a very detailed mail-out study in Allegheny County, and then a study of 1,000 respondents on MTurk. Here are the average results. The dark bars on the left are for the 2 samples for air pollution. The light bars on the right are the average results for carbon dioxide. And you can see that basically people do not know the difference. The average results suggest that on average people think air pollution stays in the atmosphere significantly longer than in fact it actually does, and that carbon dioxide doesn't stay there anywhere near as long as it actually does. You might ask, but is there an individual to individual change? And the answer is no. These are results on an individual basis, and you can see that 70% of our respondents in both samples are saying same residence time. Now, we find that really disturbing, because if you believe that, then people would be able to think, I don't know if this climate change stuff is real or not. But if it ever gets serious enough, we'll just fix it by reducing emissions in the same way that we fixed air pollution in places like Pittsburgh and Los Angeles. And of course, that doesn't work. I mean, once the stuff is there, we're stuck with it. So now Rachel, with our supervision, is going on to try to figure out ways to communicate so that to help people understand why there is this very different residence time. And we're also working on what the Academy and the science community calls climate attribution. Whenever there's a big event, a hurricane or something, there's always questions, did climate change cause this? Well, of course, climate change doesn't cause it, but it may change the likelihood. And so we're using spinner boards. And so in this case, for example, I'm going to spin the spinner, and if it lands on the red, a specific extreme event like a hurricane will happen in the next year. And then with climate change, basically what happens is that the red gets a little wider. We can do the same sort of thing with strategies to explain changes in event intensity. And when we give these to lay people, they, 1, understand it quite quickly, and 2, can accurately describe the idea to colleagues.
All right, so, excuse me, what do we think we've learned from collaborating in these interdisciplinary projects? Well, in terms of developing communications, we think we've learned that communications are more effective if we address what people need and want to know, not just by covering what experts think is important, but also what the intended audience members think is important. We've also learned that communications are more effective if we use understandable wording so that people actually understand what we're talking about and can use the information in their decisions. And we've learned that it's important to test the effectiveness of communications before their dissemination. If you don't test your communications, then you run the risk of spending time and effort in disseminating something that actually doesn't help people to make more informed decisions. To develop those communications, interdisciplinary research is needed, with domain experts such as Granger providing technical expertise to ensure the accuracy of the communications, and social scientists, perhaps like myself, to provide expertise on research with the intended audience so that we cover information that people need and want to know, so that we figure out what wording to use so that they can understand it, and so that we can test communications for their effectiveness before their disseminations, because these are topics that social scientists are trained in. Now, of course, we've already talked about this morning a little bit, that interdisciplinary collaborations can pose challenges, but you can also think of those as strengths. It's all a question of framing, like with many communications. So sometimes we find, and this could be a challenge, that we aim to solve different problems because I'm more focused on the psychology and Granger may be more focused on the technical issues. But you can see that as a strength because our work may be more useful as a result because it builds on psychology and the correct technical issues to develop communications. Our theories and methods differ, so sometimes we have different approaches, but again, that may be a strength because our work as a result is grounded in both of our fields. We also find, I think with any interdisciplinary collaboration this can happen, that we use different academic language and have a different academic culture in our fields. Sometimes it's like traveling to a foreign country and you don't really understand what people are saying or why they're behaving in a certain way. But if you make an effort to learn a few words and to try to understand why people behave in the ways that they do, you can get along and work well together and understand each other. And have a productive collaboration. Another challenge can be that our papers do not always fit journals that are targeting one specific discipline, but we have found that there are enough top journals that want interdisciplinary projects, and we've been able to publish there. Another challenge is that many traditional academic departments may be confused by us. I have definitely been asked, so are you really a psychologist? Because the topics on which I focus are not all traditional psychology topics. But we have both found jobs in groundbreaking academic departments. Engineering and public policy at Carnegie Mellon is a department that has hired engineers, physicists, people working on important technical problems, as well as psychologists and social scientists who work together to inform policy. And then I work at the Leeds University Business School now, which explicitly encourages interdisciplinary research because it recognizes that real-world problems cannot be resolved by looking at them through the narrow lens of just one discipline. So it also has helped that we enjoy working together, that we have complementary strengths and insights which combine into novel ideas, with Granger bringing expertise in natural science and me bringing expertise in social science and statistics. We've also had adequate funding, including from NSF. We've worked in supportive environments. We've been recognized by our fields. And perhaps most importantly, we have worked with amazing students who have helped to find the balance between our two approaches.
So we'd like to thank both the National Science Foundation, who has supported a great deal of this work, EPRI, and our two academic departments, Carnegie Mellon and the University of Leeds. So thanks.
Thank you.